Today I'm going to share some experience with you about how do we evaluate the NoSQL database for our system. So first, let me give you a brief introduction of our company and the game we are making. So Tencent is a global internet company, and it runs a lot of game business, including game development and game operations. And the studio I'm in, which is Storm Games, is one of the game studios owned by Tencent. It's located in Concord, Massachusetts. So we are currently focusing on a social game called Robo Rising. This is a game that targeting to a mid-core user, which means that let the user to play on Facebook, and we have some very deep game content and a very good graphic, as you can see from the pictures. So if time permits, I'm going to show you a video of that game. I'm sure you're going to add some fun to the presentation. So back to the tech. So like many other web-based games and like many other web-based applications, our server backend is basically a web stack server. So the client sends HTTP requests to the server, and we use a load balancer to distribute that evenly to the web servers at the front end. And at the back end, we have a cluster of game servers, which will deal with all kinds of game logics. And we use a database system to persist all the user data. So here comes the problem. What kind of database we're going to pick? Traditionally, the first thing coming into your mind is the transactional database system, like MySQL. And we then realize there is a bottleneck of that because it's not easy to scale, and the performance is not as good as we are expecting. Then we start to explore some other options. Then we realize NoSQL might be a good choice. So for people who do not know NoSQL, that's basically opposite to the traditional database system. It does not use SQL like the name. It uses a key-value pair to store the data into the database. So basically, you give it a key, like a user ID, and a value, which is the user content, and you just put that into the database system. That is NoSQL. Why we do use NoSQL? The easiest thing for you to do first is just to Google that, and this is exactly what we did. Just type why NoSQL in your Google, and you will find a lot of good document articles about that, and that will be very helpful. Particularly for us, first, all our data are user-centric data, which means that everything could be easily mapped into a key-value pair. So like we have a user ID, and we have everything associated with that user. Then we can easily put that into the NoSQL solution without any extra work. So this is the primary thing that we are going to pick NoSQL. And another benefit NoSQL provides is its native scalability. So if you heard the word sharding, it means the system will automatically shard all the storage. Basically, like you since it's used the key-value pair, so it hashes your key into a particular number, and it knows the backend database system knows where this key value is going to be sent to. So it automatically scales your system if you add more nodes to the database system. And it's easy and simple because it avoids like database schema, and you do not need, if you change anything, it happened automatically. You do not need to change the database table structure or anything else. So now let's talk about the evaluation stuff. So when you start to evaluate a third-party software, you usually have a problem associated with that. Typically, you are experiencing a bottleneck. Like what I mentioned for our situation, we saw a bottleneck at our database side. And it's not scalable, it's slow, and we want to find a solution which will overcome that bottleneck, right? So this is, of course, your primary goal, and you want to overcome those kind of problems. But typically, when you start to looking at those kind of solutions, you will find a lot of solutions. You are not just finding one solution. So at this time, you need to do some evaluation. And you need to define additional goals for that evaluation. So I call them 4 fits. The first thing is that third-party solution has to fit into your own system. So I don't care how fancy a third-party software or service is. If it can't fit into your system, it makes no sense. Right? For example, if the API they provided is only Java API while your backend system is using C++, I mean, there is no meaning using that. Other than that, there are something that you need to care about. That is their design philosophy. So this is what I meant. It has to fit into your team. So every team has their own developed philosophy. Like some team prefer a message-based system. Some team prefer a remote RPC call, remote procedural call system. And if you have a third-party system that does not really fit into your development strategy or development philosophy, it will create additional conflicts for your team. Right? We don't want to have that. Another thing, of course, you can see that fits into the budget, right? I mean, you care about that, your boss care about that. And by saying fitting into the budget does not mean how cheap the product is. You need to evaluate the performance of the product. If, for example, if a database system can provide all your requirements within 10 servers, but another database system requires 20 servers, and they are at the same price of each server, so it's a clear choice. You're going to pick the prior one. Another thing is it has to fit into your long-term plan. I mean, we should not be short-sighted at any time. When you consider to use a third-party software, you need to look at the trend. You need to know how this, for example, in 3 years, how this is going to be developed to, and will your next project be benefit from that? These should be something you're looking at. So based on these goals, we can define certain criteria for your exact evaluation. So these are some of the criteria we're looking at when we are evaluating the NoSQL solution. I'm not going through them one by one, but I'm going to describe the process which will have them embedded. I want to talk about one thing, which is the sharding strategy. It's very important that you have a very good sharding strategy of your NoSQL solution, because they all use different sharding strategy. Like, for example, if you heard of Memcache, it's using a hash solution at the front end, which means at the client side. If you add one more node, you have to restart the client, right? Couchbase provides a slightly different sharding strategy. Everything happened at the server side. If you add one more node, you do not have to restart your client. You just let that go. That provides like 0 downtime. This is pretty awesome. So let's go back to the process. At the very beginning, we do an internet search, and we talk to some of the friends or other teams. We want to understand the existing technologies. And we typically, after that, we have a few choices. Like for this NoSQL solution, we have 4 choices: Couchbase, MongoDB, MySQL cluster, and DB shards. All of them are great products. Then we try to install all of them and see, based on that, we'll understand the system requirement. For example, what kind of operation system they're going to support. We can also understand if that software will provide detailed documentations, and if that software provides some use cases. These could be very helpful, and if you will see, sometimes when you evaluate one product, some of the open source products, they really lack of documentation. This is not good for your long-term plan, right? If you see some problems, you can very hard to find an answer to that. Another thing, next, basically, we're going to do a stress test together with a accident simulation. Basically, based on these kind of stuff, we want to understand the system performance and the stability. We have a very good tool developed in-house. But if you're going to pick up some tools, like some open source tool could be useful, like Apache Bench, they could be very helpful for you to do some stress test. And for the accident simulation, we basically just try to, when the server is running, we try to, like, for example, turn off one of the nodes. We take away one of the hard drive. We will see how the system reacts to that. Will the client experience any downtime? So basically, these are some of the stuff we're looking at. So next, once all of them has been passed, typically there are not much choice left, right? So typically you can already find one which fits into your system. But if you still have more candidates in your bucket, you should be able to do a real system integration, which means try to connect the database system into your backend server and see how the compatibility is. And at another side, you will see how much coding effort you're going to spend in using that new system. At the same time, typically there's going to be a salesperson try to call into you, and probably another marketing person try to talk to you. My philosophy is talk to them, because they can be helpful. They can help you to set up some technical calls with their technical person, like what I meant, next technical consultant. And it's very helpful. When I do some evaluation, I talk to many of the tech persons in different companies, and I understand a lot. I learned a lot. So based on all these information, you will be able to compile a comparison matrix. And based on the comparison matrix, you can make a decision on that. And you can either just present the matrix to your boss and let your boss to make a decision, or you can just make a decision by your own. So here is a comparison matrix we have. I do not omitted the actual results because most of the results are case by case, and some of the results are a little bit company confidential. But like the structure is exactly what we have, and hopefully it could be helpful. So once we finish that, we integrate the system that basically the Couchbase cluster is exactly what we are using for the database system. And Couchbase provides a Memcache API, which I should call that Memcache compatible API, which perfectly fits into our system. So it spent me like just an afternoon to change all the Memcache API to Couchbase API. It's very straightforward. And I'm going to show you one of the performance tests we had. Basically, it's Adtest or set test. So the server setup we're using is a Xenon CPU, just one CPU and 32 gig memory. And we use HDD. And the network we were using was 1 gigabyte Intel network. The test setup, we use a 1,000 kilobyte, a 1 kilobyte blob, and we try to insert that by either 4 connections or 50 connections. So 50 connections will be more like a full throttle environment, and 4 connections more like of a casual environment. So that's the result. And we got like more than 15K inserts per second in just one of our server, which is a very good result. It beats all other systems. So like I can give you a comparison. So the Memcache when we are testing, which is a pure memory solution, it only generates 20 more K inserts per second with the same setup. So in this case, Couchbase is doing pretty well. So why do we pick Couchbase? There are several reasons of picking that. First, it passes all our hard requirements. Our ops, so Tencent is a pretty large company, and we run the ops team on a different department, and they have a very strict criteria to adapt new system into the existing structure. And so when I asked them to evaluate Couchbase for us, they did a lot of tests on that. So I mean, luckily, Couchbase passed all the hard requirements they defined. Like from the scalability, it's evenly distributed all your requests to the server nodes, and it can add and remove server nodes with no downtime. I mean, as you can all observed. And for the stability, they did a very detailed stress test and accident simulation. And the maximum environment, they used 10 server nodes, and they basically did not create any of the accident, which is unrecoverable. So, and during their test, there is no data has been lost. Another thing is that from the developer side is it's easy to integrate. And like what I mentioned just now, it used Memcache API. I really like Memcache because it's a well-proven API. It supports a lot of features. Basically, all our requirements could be done by Memcache API. And I can just give you a very good example. So let's say you have a multi-thread system that you have multiple server trying to connect one same data, right? You don't want the data to be corrupted because it's in a multi-thread system, and you don't want to add some lock system to that, which will greatly reduce the performance. So Memcache provides a API called compare and set, which is CAS. It's basically like assume there are going to be no collision happen, but every time when the server tried to load something from the database, it set a number over there. And every time when the server tried to set something in the database, it also set a unique number over there. And when you load the data from the database, it loads the data with you. And next time when you set that, it will compare the data you loaded with the data already in the database. So this will guarantee there are going to be no collision. So if your number is different from the one in the database, it will just fail your operation. So you know someone has already set the data prior to you. So this is one of the cool features provided by Couchbase, provided by Memcache, and Couchbase use that. Also, I would like to say that Couchbase provides very clear documentation and tutorials. It's very helpful. We almost have no hesitation of using that. It's so easy to read their document, and we do not even need to look up online. Just to follow their tutorial, you can get everything set. And like what I mentioned, minimal coding effect. To integrate Couchbase API took me just a few hours in one afternoon. So another thing really cool about Couchbase is its user-friendly tools. Couchbase provides both the web-based graphic tool and the command line tool. I would say Couchbase has the best tool of all other NoSQL solutions. It's really good. Our ops really like that. And of course, the great performance and tech support provided by Couchbase also give us a very good reason using Couchbase. So by using Couchbase, what we have, so of course, it's easy, quick adaptation. There's no problem at our developer side. So they didn't even know that we changed from our original Memcache to Couchbase, and they are very happy about that when we told them the result. And our ops team are pretty happy about that, like what I mentioned. I'm not sure if DBA is happy about that because basically they do not need to do anything. And since our open beta about the Robo Rising, the game we are making in August 22nd, we have zero downtime for the whole server system. I mean, thankful to the Couchbase system. And we actually did a lot of data upgrade during since the open beta, at least three release and 3 data upgrade, and none of them creates any, case that we have to restart, not restart, have to terminate the server, have to generate any downtime. So like what I mentioned, it's schemaless. I mean, if you change your data structure, you just change the document type. And it all happened at your backend server. You do not need to change anything at your database side, right? It just magically happened. All right, looking forward, someone may concern that what's the real system capability of Couchbase? I mean, how much load it can survive? I do not have any concern about that. Our test shows that so basically the first thing is Couchbase is pretty much linear increasing. If you're adding one more node, you get linear increase of the performance. And I mean, we do not do a very high level test because we think, I mean, the worst scenario is that we have like a couple million DAU, which is a daily active user, and like 1 million peak active user. And we actually tested on that, and Couchbase can get that done with just 10 nodes. So, I mean, there is no reason to find basically a bottleneck of that, because it can just satisfy all our requirements. And about some of the new features, if you read some of the document Couchbase sent out recently, they are trying to releasing a Couchbase 2.0, which is currently in beta. They provide a lot of cool features over there. Something I want to say about their cross-IDC replication. So if you have your if you have multiple IDC, and they can help you to replicate the data from one IDC to another, which will greatly mitigate kind of disaster. And I mean, there could be other issues could be greatly improved. Another thing is their incremental map reduce. And this could be useful to do a lot of indexing, laddering, those kind of stuff. We haven't used that feature yet, but I'm very looking forward of seeing that. And I mean, it's very helpful for casual games, and I'm sure that'll be helpful for other applications. So like our game is a casual game, which is or a social game. And I always say there are other types of application that could use Couchbase. I mean, I'm not expert in those domains, but I would focus on the game industry. Some of the traditional online game, like massive multiplayer game, MMO game, those games could also use Couchbase. I mean, originally, because I'm from a MMO industry, and originally we use shared memory, and we still persist the data to the like a traditional transactional database system like MySQL. And I will say Couchbase can be a really good fit to that system. I do not see any problem of adopting Couchbase in that scenario, because next we are going to moving forward to integrate some MMO feature into our system. And we did some early evaluation, and we found that's totally doable to integrate Couchbase into a existing MMO stack. All right, so since we have enough time, I'm going to show you a video of our game. game is currently in open beta called Robo Rising, and if you're interested, you can just try that on Facebook. Right. Any questions about the presentation? That's a question session. Yes, so the question is if we've done any test against the disk and see if how many writes can go into a disk per second, right? Something like that. Right? Okay, so we've done some of the tests. I would say the bottleneck usually are the disk. And we talked to Couchbase during our evaluation, and they said if you want to improve your performance overall, SSD is recommended. But like our test is based on HDD, which still provides a pretty satisfactory result. So we did not change to SSD. I would say that the bottleneck is the disk, but it's not really a big deal. Couchbase actually provide a very good solution to write the data from memory to disk. Because if you write the same document several times, it will queue you up. And it will, if the disk throttle is pretty high, and it will just omit the middle ones and just write the latest one to the disk, which saves a lot of the writing operations. The question is, how many disk writes per second can we achieve at most? That was the test. The test we did for the HDD was, let me just go back to the test results. All right, so this result is basically limited by the HDD. So 15,000 per second for a 1K blob writes every time is the result we got. So we found the CPU is pretty light. It's about 2 and 3%. And the memory, I mean, you can see we have 32 gigabytes memory. And the performance hit was at the HDD. Basically, this is the result we got. Any more questions? All right, I think if there's no questions, then we can move on to the next sessions. You think okay? Thank you.